Hi students, welcome to Sankalp Learning Classes. So in this session, we'll be discussing the remaining questions of 5 marks from the chapter Application of Integration. So straight away, we are moving on to first questions of the session. Find the area lying in the first quadrant, and bounded by the circle x square plus y square is equal to 4 and the lines x equal to 0 and x equal to 2. Okay, so we have to find out the area which is in the first quadrant and how is this region formed? It is bounded by the circle x square plus y square equal to 4 and lines x equal to 0 and x equal to 2. Okay, so if we draw the figure, then how will be it? So I'm going to construct the circle. Okay, so it is x square plus y square is equal to 4, isn't it? So what does that mean? The radius is we know the standard equation of a circle is x square plus y square is equal to r square, and where r is the radius of the circle, isn't it? So here what is it? It is x square plus y square is equal to 4, which means 4 can be written as 2 square, right? So what is r? R is equal to 2. R is equal to 2. The radius of the circle is 2. So which means what will be the distance from the origin to this portion? It will be 2. So what is the coordinate there? It is 2, 0. So what is the coordinate here? It is 0, 2. Isn't it? The coordinate here will be 0, minus 2. And this one will be minus 2, 0. So this is our circle. And which is the portion that we have to find out the area? Which is that portion? It is the area that lies in the first quadrant. Means this is the first quadrant, right? And it is bounded by the circle. It is bounded by the circle means that. Here you can see this is a circle. This is the part of the circle x square plus y square equal to 4. Bounded by the circle and lines x equal to 0. What is x equal to 0? X equal to 0 is this, isn't it? And what is x equal to 2? What is x is equal to 2? X is equal to 0. Actually, this is not x equal to 0. This is x equal to 0, isn't it? X is 0 means in this line y-axis. Y-axis we can see that x is equal to 0. And here x equal to 2 means this line. X equal to 2 means this line, isn't it? If you draw a line like this through passing through 2, here in any point, if you take what is the value of x, any point in the line, we can see that the x is 2 itself, isn't it? That's why it is a line x equal to 2. So this is a line x equal to 0. This is the line x equal to 2, and the portion should be bounded by the circle. Okay, and it should lie in the first quadrant, which means this is the area that we need to find out the area. Portion that we need to find out the area. Alright, which is that portion? It is OABO. It is a portion OABO. And how will you do it? So here you can clearly see that x is varying from 0 to 2. So the required area is equal to required area is equal to integral 0 to 2. It is varying from 0 to 2. Here x is varying, so we have to integrate it with respect to x. So it is dx, isn't it? So what is the function here? Function will be y. Function will be y. And from this you have to find out what is y. X square plus y square is equal to 4, which means y square is equal to 4 minus x square. So what is the value of y? Y equal to root of 4 minus x square. What is y? Root of 4 minus x square. So here you substitute that one. 0 to 2, root of 4 minus x square into dx. Root of 4 minus x square into dx. And this one you can write 0 to 2 root of 2 square minus x square into dx. It is root of 2 square minus x square into dx. So what is it actually? It is integral root of a square minus x square dx. We have already discussed it in the previous session. What is that formula? What is the integration formula? Integral root of, we know integral root of a square minus x square dx is equal to x by 2 root of a square minus x square plus a square by 2 sine inverse of x by a. Sine inverse of x by a. This is a formula, isn't it? So here in the place of a, you can see it is 2. Here a is equal to 2, isn't it? So integral 2 square minus x square. Integral 2 square minus x square, and it varies from 0 to 2. 2 square minus x square dx is equal to x by 2 root of 2 square minus x square. 2 square minus x square plus 4 by 2. A square is 4, right? 4 by 2 sine inverse of x by 2. Sine inverse of x by 2. It varies from 0 to 2. Now what you have to do? You have to put the upper limit. Upper limit minus lower limit will give you the value of integral 0 to 2, 2 square minus x square into dx. Isn't it? So if I substitute the upper limit, what is the upper limit? Upper limit is 2. So if x is equal to 2, what will happen here? 2 square minus 2 square. 2 square minus 2 square is 0, right? So that term gets, the value of that term will be 0. So the first term is 0. And now in the second term, if you put 2, what happens? It is 4 by 2 is 2. Sine inverse of 2 by 2. Sine inverse of 2 by 2 minus. And now if you put the lower limit, it is 0. X is equal to 0, right? So this term will be equal to 0. And what is the value of this term? It is sine inverse of 0. Isn't it? 0 by 2 0. So sine inverse of 0 is 0. So that term is also 0. Alright, so this is equal to 2 into sine inverse of 1. 2 into sine inverse of 1. What is the value of sine inverse of 1? 2 into pi by 2. 2 into pi by 2, what is it? It is pi square units. It is pi square units. So what is the area of that particular portion that lies in the first quadrant, but it is bounded by, it lies in the first quadrant, but it is bounded by x equal to 0 and x equal to 8. Right. X equal to 0 and x equal to 8. I'm sorry, this is not a figure. So this is our figure. X equal to 0 and x equal to 2. It is nothing but pi square units. Okay. Now, moving on to our next question. Find the area bounded by the curve y equal to sin x between x equal to 0 and x equal to 2 pi. Find the area bounded by the curve y equal to sin x between x equal to 0 and x equal to pi. Here also we need the graph of the function. This is 0, this is pi by 2, and this one is pi. This is 3 pi by 2, and this one is 2 pi. This one is 2 pi. Okay, so here the curve is y equal to sin x. What is sin 0? Sin 0 is, we know, I'm sorry, sin 0 is 1, right? Sin 0 is 0. Sin 0 is 0. What is sin pi by 2? Sin pi by 2, let this be value be 1 and this be minus 1. Okay, we know the value of sin varies between minus 1 and 1, isn't it? So sin pi by 2 is 1. Then what about sin pi? Sin pi is 0. And what about sine 3 pi by 2? Sine 3 pi by 2 will be minus 1. Will be minus 1. What is sine 2 pi? Sine 2 pi is 0. So if you draw the graph, it will be like this, isn't it? Then 0. Then it reaches to minus 1. Then at 2 pi, it reaches to 0. All right. So this is the graph of sine pi. Y equal to sine pi within the interval 0 and 2 pi. You have to find out the area. So which is the portion that you have to find out the area. So these are the portion that you have to find out the area. So this is our required area. Okay. Here also what will we do? These two portions you can see that both are same. One is below the x-axis. Below the x-axis, what happens is that if you find out the integration and if you substitute the values, you will get a negative value. But we know area is a positive value. Area, so we only consider the numerical value. So in order to consider only the numerical value, we take the modulus or we take the absolute value of that, isn't it? So x-axis we only take the below the x-axis we only take its value, numerical value. Okay, that is if it is negative you take the modulus, then it will be positive, right? So we only take the numerical value of that portion, which means you can see that both these portions are same, isn't it? The area of both these portions will be same. So what we are going to do is that we are just multiplying it with 2. We find the area of this portion. Okay, 0 AB. Okay, we find the area of this portion and then if you multiply it with 2, you will get the total area. You will get the total area. Alright, so that's what we are going to do here. So the required area is equal to required area. Required area is equal to what is the answer? It is 2 into. How will you find out the area of this particular portion? How will you find out 2 into area of region OABO? Okay, OABO. Which means how will you find out that area of that portion? It is varying from 0 to 0 to pi, isn't it? 0 to pi, and which is a curve that is bounded here. It is y is equal to sine x, and it is varying from 0 to pi. Okay, integral 0 to pi, and what is varying here? X is varying, so we have to integrate it with respect to x, which means dx. All right, and then here it will be y, and what is y? 2 into integral 0 to pi. Y is sin x. Okay, sin x dx. 2 into integral 0 to pi sin x dx. Okay, so this is equal to next step. In the next step, 2 into integral 0 to pi sin dx. What is integral sin x? It is integral sin x is minus cos x, right? So it is integral 2 into minus cos x. It is minus cos x. It is varying from 0 to pi. It is varying from 0 to pi. So this is 2 into minus cos pi minus cos 0. Minus cos pi minus cos 0. That is 2 into minus cos pi plus cos 0. Minus cos pi plus cos 0. So that is equal to what is the value of cos pi? What is the value of cos pi? We know cos pi is minus 1, isn't it? So this is 2 into minus 1 plus what is cos 0? What is the value of cos 0? Cos 0 is 1, right? So this is equal to 2 into, this is plus 1, right? 1 plus 1. That is 2 into 2. 2 into 2 is equal to 4 square units. 4 square units. 2 into 2 is equal to 4 square units. Okay, find the area of the region bounded by the line y equal to 3x plus 2. Then the x-axis and the ordinates x equal to minus 1 and x equal to 1. So first of all, we need the figure, isn't it? Then only we get to know which is the portion that we need to find out the area. All right. So first we need to construct the, what we have to do? We have to construct the graph. All right, so this is our x-axis and y-axis, and it is y equal to 3x plus 2. So we have to substitute the values, right? So let this be x, and this is y equal to 3x plus 2. So if x is equal to 0, then this is 3 into 0. 3 into 0 is 0. 0 plus 2 is 2. Just put the value of x in this, then you will get the corresponding y value. Okay, if you put minus 1, x is equal to minus 1, it is minus 3 plus 2. Minus 3 plus 2, isn't it? Minus 3 plus 2 is minus 1, right? Now, what if we put 1, 1 x is equal to 1, 3 into 1 is 3, 3 plus 2 is 5, isn't it? Then 2. Okay, 3 into 2 is 6, 6 plus 2 is 8. Then if we put minus 2, it is 3 into minus 2 is minus 6 plus 2 is minus 4. Minus 6 plus 2 is minus 4. Okay, so how can you draw the graph here? If x is equal to 0, if x is equal to 0, it is y is equal to 2. Okay, y equal to 2. Let this be 2. Okay, then if it is minus 1, then minus 1, it is minus 1. Let this be minus 1. So here, right? Now, what is, if it is 1, then it is 5. Okay, 1. If it is 1, then it is 5. So this is 2, which means 5 will be somewhere here, right? Somewhere here. So actually the graph of the function will be like going like this. Okay, this will be the, let this be 2, okay? So this will be the graph of the function, right? Now the ordinates, what is the ordinates? X is equal to minus 1 means, so this is x equal to minus 1. And now what is x is equal to 1? X is equal to 1 means this will be the graph. All right. I'm sorry, I have made a mistake here. This 3x plus 2 should pass through, it should pass through this minus 1, right? The graph is like this. Okay. Y equal to 3x plus 1. The graph is like this, 3x plus 2. Okay, so this is our x equal to, this is x equal to minus 1, and this is equal to x is equal to 1. Okay. Now, which are the portions that we need to find out the area? So this is bounded by x equal to 1 and y equal to 3x plus 2. Isn't it? Similarly, is there any other portion that is bounded by the specified portions x equal to minus 1, x equal to 1 and y equal to 3x plus 2? Here you can see this portion, isn't it? X equal to minus 1, and it is bounded by x equal to minus 1 and y equal to 3x plus 2, isn't it? So these two portions are the required area. Okay, this is formed by the curve y equal to 3x plus 2, x equal to minus 1 and x equal to 1. Okay, so how will you find out the area? You have to find out the area of this portion as well as this portion. So let's give some name for this portion and all. So let this be C, okay? This is A, this is B. Okay, A, B, C. Now, what is the portion? This is D and this is E. All right, so it is CDE. It is a portion CDE, and this one is a portion, this is a portion ABC. So we have to find out the area of these two portions. So what is the required area? Required area is equal to, required area is equal to area of ABC, region ABC, plus area of CDE. Okay, so first we can find out the area of region ABC. All right, area of ABC. So let's see the graph. So this is a graph, okay? So this is a graph. This is the portion ABC. It is bounded by y equal to 3x plus 2, then x equal to minus 1. So how will you do it? You need to know the point here. Which is the point here? It is minus 1. Isn't it? The coordinate of point A is minus 0. It is actually minus 1 comma 0, isn't it? It is minus 1 comma, it is minus 1 comma, A is minus 1 comma 0. And what about the point C? What about the point C? We don't know the coordinate of C, right? So we have first, we need to find out the coordinate C. Then only we can find out the variation of x. That is, x is varying from minus 1 to where? Okay, we need that point, right? We need to know what point C is. So how will you find out? It is the intersection of y equal to 3x plus 2 and this x-axis, isn't it? Y equal to 3x plus 2 and x-axis. It is the intersection of y equal to 3x plus 2 and x-axis. So we know in the x-axis, y coordinate is 0. Isn't it? In the x-axis, y coordinate is equal to 0, which means y equal to 0. Okay, here it is actually the intersecting point. See, intersecting point is intersecting y equal to 3x plus 2 and x-axis. Y equal to 3x plus 2 and x-axis. And in the x-axis, we know y is equal to 0. Everywhere y coordinate is equal to 0, which means 3x plus 2 will definitely be equal to 0 in that point. Isn't it? Y is equal to 3x plus 2. So 3x plus 2 will be equal to 0. So what is 3x? 3x is equal to minus 2 and x is equal to minus 2 by 3. X is equal to minus 2 by 3. X is minus 2 by 3. All right. So the area, so the coordinate will be C is equal to minus 2 by 3 comma 0. Minus 2 by 3 comma 0. So area of ABC. Area of ABC is equal to integral minus 1 to minus 2 by 3. Integral minus 1 to minus 2 by 3. It is varying, x is varying from minus 1 to minus 2 by 3. That is, we have to integrate it with respect to x. That is dx. Then here it will be y. Here it will be y. So what is it? Minus 1 to minus 2 by 3. Y is 3x plus 2. Y is 3x plus 2, isn't it? 3x plus 2 dx. So this is equal to 3 into x square by 2. What is the integral of x? X square by 2 plus 2 into x. 2 into x, right? Into minus 1 to minus 2 by 3. Right now, if you put the upper limit, what will happen here? If you put the upper limit, that is equal to 3 into minus 2 by 3 the whole square divided by 2 plus 2 into minus 2 by 3. This is upper limit, right? Minus 3 into what is the lower limit? Minus 1 the whole square by 2, then minus. Isn't it? That is, actually it is minus the lower limit. We have to put the bracket, right? Minus, then 2 into x. 2 into x is minus 1. 2 into x is minus 1. So this is actually 3 into minus 2 by 3. The whole square is actually 4 by 9 divided by 2 will become 1 by 2. Then minus 4 by 3 minus, we are removing the bracket. Okay. So if you are removing the bracket, the sign here, the sign will change, right? So this is actually minus 3 into minus 1 the whole square is 1. So it is 3 by 2 then plus, right? So this will become minus of I'm sorry, this was actually plus. I'm really sorry, that was actually plus. So the sign, now the sign will change. So this will become minus 2 minus 2. All right. Now, if you cancel this and this one, this is actually equal to, this is actually equal to 1 by 3 minus 4 by 3 minus 3 by 2 plus 2. Right. So this is equal to minus, this is minus 3 by 3 minus, what is 3 by 2 plus 2? 3 by 2 plus 2 is actually 3 plus 4, right? This 7 by 2. So the answer is, here it is actually minus 6, then minus 21 by 6. So this is equal to minus 27 by 6. Um, just a minute. Okay, let's do this step once again, all right? So this one will be 3 into, it is 3 into 4 by 9 divided by 2, it is 1 by 2 into 1 by 2. Then this one is minus 4 by 3. Right, minus 4 by 3. Then minus of this one will be 3 by 2 minus 2. 3 by 2 minus 2. Alright, so if you cancel this one, this is 2. So this is equal to 6 by 9 minus 4 by 3 minus, this is 3 by 2 minus 2. And what is this? If you make it 9, this will be 4 into 3, just 12, right? 4 into 3, then this is also into 3, then the denominator will be 9, right? So this is 9, and 6 minus 12 is minus 6, minus 6 by 9 minus, what is 3 by 2 minus 2? 3 by 2 minus 2 means 3 minus 4, it is 3 minus 4 is minus 1, right? So it is minus 1 by 2. So this is equal to minus 6 by 9 plus 1 by 2. Minus 6 by 9 plus 1 by 2. So this is minus 12 plus 9 by 18. All right. minus 12 plus 9 by 18. So what is the value here? It is minus 3 by 18. Here you have to take the modulus value, isn't it? I have already told you that if the region is below the x-axis, you should always consider the modulus value. Okay, then we need only consider the positive part or the numerical value. So you have to take the absolute value or modulus. So if you take the absolute value, this one will equal to 3 by 18. So what is 3 by 18? We can cut short, right? 3 by 18, we can write it as 1 by 6. 1 by 6. Okay, now what is the area of the portion CDE? Area of CDE is equal to integral minus 2 by 3 to 1 y dx. Isn't it? Here, if you observe the graph, you can see that it is varying from here, it is minus 2 by 3. This is minus 2 by 3. Minus 2 by 3 to 1. This is varying from minus 2 by 3 to 1 and this bounded by the curve y is equal to 3x plus 2. Alright. So that's why I wrote it like this. Minus 2 by 3 to 1 y dx. X is varying, so we have to integrate it with respect to x. So it is dx and the function is y. So this is minus 2 by 3 to 1. Y is 3x plus 2. 3x plus 2 into dx. 3x plus 2 into dx. So this is 3x plus 2. 3x plus 2. I'm sorry, we have to integrate it, right? What is the integration of 3x plus 2? It is 3 into x square by 2 plus 2 into x. It is varying from minus 2 by 3 to 1. Minus 2 by 3 to 1. So this is equal to 3 into 1 by 2 plus 2 into 1. 3 into 1 by 2 plus 2 into 1, right? Upper limit, then minus lower limit. 3 into minus 2 by 3, the whole square divided by 2 plus 2 into minus 2 by 3 plus 2 into minus 2 by 3. So this is our previous step. So this is equal to 3 into, we put the upper limit, right? So it is 3 into 1 by 2. It is 3 by 2 plus 2, right? 3 by 2 plus 2 minus 3 into minus 2 by 3, the whole square by 2. That is 3 into 4 by 9 into 1 by 2 minus 4 by 3. 2 into minus 2 by 3 is minus 4 by 3. Right? So this is equal to 7 by 2. 3 into 3 plus 2 into 2 is 4. 3 plus 4 is 7. 7 by 2 minus, what is the value here? If you cancel it, you will get 6 by 9 minus 4 by 3. Again, we have already found out the value here. 7 by 2 minus 6 by 9, right? Minus 6 by 9. So this is equal to 7 by 2 plus 6 by 9. So what is 7 9s are 63 plus 12 by 18. So this is equal to 75 by 18, which is equal to 25 by 6. Isn't it? That is equal to, if you cancel it with 3, you get 25 by 6. So the required area is the sum of those two, right? Required area is equal to 1 by 6 plus 25 by 6. 1 by 6 plus 25 by 6 is 26 by 6, that is 13 by 3. 13 by 3 square units. 13 by 3 square units. Alright, now we have one more question. So that's the last question of this chapter. The area bounded by the curve, y equal to x into mod x, x-axis, and the ordinates x equal to minus 1 and x equal to 1 is given by. So it is bounded by the curve y equal to x into mod x. Then x-axis. Then the ordinates x equal to minus 1 and x equal to 1. So first we need the graph, isn't it? Then only we can find out the portion, right? So first we can draw the graph of the given function. So what is it? X is y equal to x into mod x, which means we know mod x is equal to x when x is greater than 0 and minus x when x is less than 0, right? So what happens here? This will have two parts. The function will have two parts. Y equal to x into mod x will have two parts, right? So when x is greater than 0, we know the first part is x. But what about mod x? Mod x will be x, which means it is equal to x square. When x is greater than 0, the function is x square. And what happens when x is less than 0? The first portion is x itself, but x into this minus x will become minus x, since the second part is modulus x, right? So if x is less than 0, the second part is minus x, which means this is equal to minus x square. That is, we can write y is equal to x square when x greater than 0 and minus x square when x less than 0. Isn't it? So this is the function given. Okay. So how will you draw it? Y is equal to x square when x greater than 0 and minus x square when x is less than 0. So the graph will be like this, isn't it? That means if you put 0, it will be 0. If you put 1, the value will be 1. If you put 2, the value will be 4. So the graph will go like this, right? We know the x square graph. X square graph is actually going like this, right? And for what happens if you put negative value? If you put minus 1, it will be minus 1 square, right? Minus 1 square is it's not actually minus 1 square, minus 1 square. Okay, so this will be minus 1, right? Isn't it? So the graph will be minus of x square. The graph will be like going like this. Okay, so the minus x square graph will be like this. So, in the given question, they have said that it is bounded by x equal to minus 1 and x equal to 1. So, which is the portion that we need to find out the area, which is the portion here. You can see this is one portion and this is the other portion. So these are the two portions that we need to find out the area. Okay, so which means if you give some name for that, let this be O and this be A and this be B. Let this be C, then this be D. So the required area is equal to area of AOB, isn't it? Area of AOB plus area of COD. So first we can find out area of AOB. Here you can see that this portion, okay, this portion is below the x-axis. It is below the x-axis, so definitely the area come out to be negative. So we need only the absolute value. So take the modulus of that portion. Okay, so that is you take modulus integral, and it is varying from minus 1 to 0, isn't it? It is varying from minus 1 to 0. X is varying, so you have to consider y. And what is this y? Here y is equal to minus x square and here y is equal to x square. So this portion, we are considering this portion. So the y is equal to minus x square, right? Minus modulus of integral minus 1 to 0 minus x square dx. Minus x square dx. All right. So this is equal to minus x cube by 3 minus x cube by 3 minus 1 to 0 right? So this is equal to what will be the value? You put the upper limit minus lower limit. If you put the upper limit, you can take this minus 1 by 3 outside, right? It is a constant, so you can take it outside. So x cube minus 1 to 0, x cube minus 1 to 0. All right, so this is equal to minus 1 by 3 minus 1 by 3 What is x cube? It is 0 minus 1 the whole cube, right? You have to consider the modulus value. So this is equal to 1 by 3. What is minus 1 the whole cube is minus 1. Minus 1 will become plus 1. Minus 1 will become plus 1, right? So into plus 1. So that is modulus of minus 1 by 3. That is equal to 1 by 3. Modulus of 1 by 3 is minus 1 by 3 is 1 by 3, right? So we have got the area of that portion. Now area of the above portion, COD, that is varying from, you can see the graph here. It is varying from 0 to 1. It is varying from 0 to 1. And the graph is y is equal to, the curve is y is equal to x square. Curve is y equal to x square. It is varying from 0 to 1. Y is equal to x square dx. So the integration is x cube by 3, 0 to 1, which means 1 by 3 minus 0. That is equal to 1 by 3. Therefore, the required area is equal to 1 by 3 plus 1 by 3, that is 2 by 3, 2 by 3 square units. It is 2 by 3 square units. Alright. So we have discussed the most important questions that are asked repeatedly in this chapter. So study these questions very well. I hope this session was useful to you all. Thank you.